I hope you're having a great day, and this is the 5-6 student activity book lesson. So this is on page 183, and I'm not actually there right now, but Mrs. Smith is awesome, and she'll be playing with this while I'm not there, and there are some points to pause. So this is about equivalent expressions. We saw the word equivalent with fractions. So like 1/2 is equal to 2/4, 50/100 is equal to 1/2. So they're equal, right? That's a big word in equivalent. They're equal. So when we look at this a plus 2 plus 3 and a plus 5, they're equivalent. That they just added the 2 and the 3 together and they got 5. Now, hang on a second. It couldn't have been, 5a or a multiplied by 5 because the a is separate. We don't know what the a is worth. It's a variable, but we can add the numbers together. So a plus 5 and 3 plus 4, those are not equivalent. So we're going to get started, and we're going to be looking at different examples with some diagrams and situations. So things to keep in mind, there are multiple ways how to write multiplication, like 3c, 3 multiplied by c, that kind of thing. So 3 identical packages weigh 1/5 of a gram each. That was example A. Example B is 3 identical packages weigh a grams each. And you can notice they did A plus A plus A. So that's where they got that. 2 boxes hold B books each. So there's my diagram. There's 2 B's. And if I did addition, it would be B plus B. If I did multiplication, I go a little too quickly, and it was actually supposed to be 2 multiply, little circle, B. And then if I wrote it without, it'd be 2B. I'm writing the number first, not the variable. 4 bags hold C peaches each. So I need to draw 4 bags or 4 boxes, and I'm going to label each with the letter C. I don't know how many peaches are in there, or maybe it's by weight, we're not told, but they hold C peaches. If I write this as an addition problem, it would be C plus C plus C plus C, or multiplication would be 4 multiplied by C or 4C. At this point, you can pause it and you try number 3. All right, you're back. So I went ahead and labeled each D a number, 1, 2, 3, 4, 5. So there's 5 Ds. Now I'm going to write a situation and I'm going to draw a diagram. First, I'm going to draw my diagram. I know it needs 5 boxes. I'm going to label each box D because it's that repeated addition of D plus D plus D plus D plus D. Now, time to write a situation. This can be about anything. I'm going to do 5 boxes with D books. I keep trying to save things. So there are 5 boxes and they each have D books. So 1 box has D, 2 box has D. If I multiplied it, it'd be 5 multiplied by D or 5D. High five someone next to you if they also wrote a great situation. So now we're going to use algebra tiles to model expressions. Now when we're doing this, the long ones that are kind of like a sea foam. Hi Toby, that's my cat. You could probably hear her meowing. They are like a sea foam grain. They're worth a variable. Let's go ahead and label all of them B. So do that right now. Label every single one of those tall pieces B. Now the yellow pieces you're going to label with the number 1. The tall green pieces, they are again a variable. We do not know how much they are worth. They could be worth 5 little pieces, 6 little pieces, 3, 2. We're not sure. We're actually not being told. So that's why it's a variable. Now we're going to write an expression to go along with it. Now for number 4, I have many options. I can think of, B plus B plus B plus B plus 1 plus 1 plus 1. Reminding myself that this variable, we don't know what it's worth, so I can't give it a number. We have to resist the urge to give it a number. Even though, we're mathematicians on a mission, it's our first thing we want to do is solve. In this case, we're just writing the expression. So, like I wrote myself a note up here, this is a variable. We aren't sure how much they represent. So I have 4 B's. So again, I could write this 4B or 4 multiplied by B, and I'm going to be adding 3. That is the 3 that's off to the side. Now press pause. All right, welcome back. So for number 5, and I have another equivalent expression. For number 5, I have 5 individuals and I have 1 bee. So I can write this many ways. I have 5 plus b, or 5 plus 1 b, or 1 plus 1 plus 1 plus 1 plus 1 plus b, or 2 plus 3 plus b. Either way, we're getting that same answer. Okay, press pause, try number 6 on your own. All right, we're back. Okay, so for number 6, I wrote 3b plus 3, or you could write, 2b plus 1b plus 3. So many options. So now we're going to make a quick drawing to show the model of this. I'm going to use my same idea of these rectangles. So x plus 6. So I have my long rectangle and 6 individuals. X plus 6. Modeling is awesome to help you visualize that math, especially when we're doing the expressions and equations. On number 8, it's 4x plus 1. I'm going to draw 4 long, or the ones that look like rectangles, 4 x's, and just 1. So press pause and try number 9 on your own. Okay, so number 9 is 3 plus 2x. I'm going to draw 3 individual little ones and 2 long rectangles representing my 2x. So hopefully yours look like mine. We're going to make a quick drawing of algebra tiles to help you explain why 5x minus x is not equivalent to 5. So we're thinking 5 long rectangles, and we're going to subtract it. But how do you show subtraction with that? Well, it's going to be similar to the models we saw in 5-5, where I'm actually going to get a different color to show you this, but we're going to subtract it and when I do it over here, and you'll see. So 5x minus x is the same as saying 5x minus 1x. Remember, when I have just a single one, it's still multiplied by 1. If I were to do that, I would actually have 4x left over. I wouldn't have 5. When I do the 5x minus x, I'm not taking away all of those variables. It just can't happen. So if you start with 5x tiles and you subtract one of them, I don't just say I have 5 left over. I have 4x left over. And this is a common misconception. A lot of students and adults, teachers, they'll think that the moment you subtract an x like this, well, you just take away all the x. Well, unfortunately, my friends, you do not. You're actually just taking away 1. So if you were to do that again with your model, you would show that with a circle around one of the x's and crossed out. That's like the universal sign of subtraction in these things. And you'll see I did it, crossed it out, and that's what 5x minus 1x looks like. So press pause and try number 11 on your own. All right, we're going to make a quick drawing to show and explain why 3x plus 3 is not equivalent to 6x. So if I have my 3 x's and I add 3, now, tricky, you can't just add a regular number like 3 to a 3x. It's not going to happen. Now, why? It's be like that because our 3x is separate. Our 3x represents a variable. The x tiles and the 1 tiles, so the long tiles and the little tiny tiles, they're completely different. We're going to get a different answer for that. What if, x was equal to 3? That would be a different answer than if x was equal to 10 or 5 or even 2. You cannot, you see me kind of flip it. Still with my training wheels on this iPad. You cannot combine the two. Okay, it just doesn't happen that way. Unfortunately, it'd be easy and quick, but we want to do it the right way. And doing the right way sometimes takes time. Right, we're on page 185. We're going to look at 2 different examples. The beauty of this is seeing another way to look at this. So we're going to use and draw the diagrams and think about real-world situations that we can put in our minds to understand when expressions are not equivalent. So we're looking at 3a minus 3. So 3 boxes each contain an A number of apples. William takes 3 of the apples. So there are 3 boxes. They all have a certain number. And this dude, William, he takes 3 apples. He does not take 3 boxes. That's why you notice on that final A, there's 3 little dots subtracted. Now, 3a minus 3 can't possibly be equal to a. I didn't take away everything. When I'm subtracting a number like that, that does not mean I'm taking away everything and leaving the variable. The same thing with our friend Hannah and her stamp collection. It has B stamps each, and she gives one album away. That doesn't make everything go away. So for number 12, let's get this party started. It's 4 plus 3D. Let's write a situation. Chad has 4, what could Chad have? Ooh, 4 loose baseballs. Like maybe he plays the game, maybe he's a collector. Either way. So he has 4 loose ones. They're not anywhere. But he has 3 boxes of D number of baseballs. So he has these 4 that they don't have a place, but he has 3 boxes full of a certain number each of baseballs because maybe he collects autographed baseballs. But we don't know how many baseballs are in each of those boxes. So if I were to draw a diagram of that, I would be thinking, okay, I'm going to have a big long line, and I know for sure I'm going to need a 4. Boom, I'm going to label one box with a 4. Why? Because those 4 baseballs are just fluttering everywhere. We do not know where they're at, but they don't have a home like the boxes that he already has. So I have 3 boxes with D number, right? So 3 Ds, and I need one box that has 4. That's my individual box. Right. Try number 13 on your own. Okay, here we go. Number 13. So Cindy, our dear friend Cindy, she has 2. Yeah, I think she maybe has trading cards. She has 2 packs of E trading cards. So we don't know how many trading cards are in each pack. But the cool part about Cindy is that even though she has these trading cards, and she clearly has not told us how many she has some friends. And Jill is like, hey, Cindy, here's another pack. It's just like the other ones, and it has the same amount. But how would I show that, right? Cindy still has these 2 packs. We do not know how many are in there inside there. It could be 10, it could be 12, it could be 0. And Jill says, hey, friend, here's another one. So how would I show that? It would be 2E and then an E left over, right? We could draw them together, but they really are separate. So for each of these, we're going to circle equivalent expressions. So for our friend Chad, 7D just doesn't work. I'm not multiplying the 4 and the 3. I'm not adding them. But I do know that I could say 4 plus 2D plus D, right? Because on the screen I have 2 Ds and then a D. And then that 4 plus 3D, that's exactly what the expression is. Those 2 are equivalent. For Cindy, I'm thinking that the 2 plus 2E, it's not going to work. And that it's missing on there. Now, what if I did 1, 2, 3E? Well, that works, yeah, perfect. So the far left and the far right. That's on page 185. 186, we're going to use diagrams to model expressions. So this is, I'm going to change my color. This is 5 plus 1 plus 2C, and then we describe a situation. Now, these are fun to get creative with. You could describe anything, really. So I have 4... They're 4 kids, and they're actually going to be buying a gift. So they're buying a present, a gift, maybe for a family member, maybe their mom. Shout out to Colleen Billman. I'd totally buy her a gift. So Luis, he's one of the 4 kids, he paid $5. And let's see, Rosie, she paid $1. Maybe she was like, I don't have enough money, and I misspelled paid on there. But I got $1 and I can give you. So Maya and Alex, they're the youngest, but they don't actually, they give money. But they paid C dollars each. We don't know how much they paid, but they paid C dollars. Could be $5, could be $10. So I would write that. 5 plus 1 plus 2C. Now, if I draw it in a diagram, I'm going to have one box with $5, one box that's a 1, and 2 boxes that are a C in one and a C in the other. All right, you try number 15. Okay, so number 15, if we're looking at it all together, I have 3G plus 3 plus 3. So I'm going to do 3. Now they need to be members of something. So something cool would be 3 members of the Stan family, right? Maybe they're the Stan family and they are going to pick some G apples. Now, I'm not going to tell you how many, but they picked some apples. And 3 of them picked a certain number each. And 2 of the youngest kids, they each picked 3 apples. So there's 5 members of this family total. 2 of the youngest picked 3 apples. And the 3 oldest, they each picked a G number each. So I'm going to draw a diagram of that. And I'm going to have some boxes on there of these. That's been a common theme. And I'm going to start with labeling my G's. I have 3 G's. And then I'm going to split this diagram and write 3 in one box and 3 in the other. Because I know that's what the youngest picked. So for number 14, we have some equivalent expressions. If I did 6 plus 2C, well, I mean, I like that. 8C would not be equivalent. That's a big no-no. No. Now for number 15, 9G is definitely not happening. I remember I can't just say, well, 3 plus 3 is 6, plus 3G is 9G. That's not what that means. When we're doing these, we have to think back to when we were writing the equations and expressions. What does that sound like? 1/3 of the F students at the school take Spanish. F is my total, and 1/3 is a part. So that's F divided by 3. So it's going back to things we already know. And 2F plus 2 plus 1. So Rachel bought 2 boxes of F golf balls. She also found 2 golf balls in her car and 1 in her golf bag. Like, wow, Rachel, get it together. You really need to keep track of those golf balls. So to write an equivalent expression, I know I can combine the 2 and the 1. And I can also split the F into F plus F because it is 2F. But 2 plus 1 is equal to 3. We're going to move on to page 187, and we're going to be modeling and writing expressions that are equivalent. So, number 18, there were 200 children already at summer camp, and then 3 buses arrived with G children each. So I'm imagining 200 kids are already out there. I'm adding 3 buses of G children. So I know my diagram. I'm going to start with 200. The kids were already there. And then I'm going to be adding a 1G and 2 Gs and a 3rd G because those are each a bus with G number of kids. So it's 200 plus G or G plus G plus G or 3G. I could also write this 200 plus G plus G plus G. You try number 19 and come on back. All right. A restaurant received shipment of 5 crates of glasses with G glasses. The manager dropped 1 crate, eek, breaking all of the glasses inside it. I already know this is going to be subtraction. So let's draw a diagram. I should have 5 boxes. I'm going to label them each G or they're crates, because they have G number of glasses inside them. Now I'm going to subtract a G. I'm going to grab my red and circle it and subtract it because the manager broke it. They said, bye crate, you don't need you anymore. So I could do 5G minus G, or I could be really tricky and just write 4G. That's how many G's are in there. 1, 2, 3, 4. Number 20. Describe a situation in this diagram and then write 2 equivalent expressions. Try this one on your own. Okay, if you're already back here, great. So I'm noticing there are 3 Ks, and I have, that was the worst loop. I'm just going to try to erase that from my memory. But total between those 2, 4, 6, I have 6 within the 2s. So what could I do with that? Now I need a situation, but I'm going to write my expression. So 6 plus 3K, or I could write 2 plus 2 plus 2 plus K plus K plus K, or I could do 4 plus 2 plus 2K plus K, I could do many things. So the blue triplets, they sound trustworthy. The blue triplets each ate 2 pieces of pizza, or 2 slices of pizza. So they each ate 1, 2, so there's 2, 4, 6. Now the green triplets, because these blue triplets are super competitive, these green triplets, they ate K number of slices of pizza. All right, so again, the blue triplets ate 6 pieces because they eat 2 each. The green triplets ate K slices. I mean, that sounds delicious, and then we'd be able to compare our notes. Number 88. Dear math students, that's me. Dear math students, I just had a math quiz about equivalent expressions. Here are the 2 problems I got wrong. 4x plus 3 equals 7x. 7x minus x equals 7. Can you explain why my answers are not right? And help me find correct equivalent expressions. It might help me understand if you use a model or make up a situation. All right, you work on that. I'll be right here. Cool. If you press pause, awesome. I hope you did. Now I'm going to walk you through this. So I'm looking at the 4x plus 3. I drew my boxes with 4 x's, and then I have my 3 little blocks left over. Now, I can't add those together. The 3 doesn't get added to the 4. They are 2 separate things because that 4 is multiplying by a variable. I could have written 2x plus 3, but I mean 7x just doesn't make sense. And this is again, common mistake. So now let's look at the 7x minus x equals 7. So I'm going to draw 7 of my taller tiles, my rectangular tiles, and I'm going to subtract 1. So when I do that, I don't take away the x in general. I'm losing 1. It's going to equal 6x. It's 6x minus 6x is my answer because I'm saying 7x minus 1x. So dear puzzled penguin, our dear friend, and this is just what I write. Dear puzzled penguin, and I'm wondering if he says that's you. So you cannot, and this goes to everyone in this room and myself, you cannot add the 3 to a 4x. It's just not going to happen. You can't add a number to a variable like that. They are 2 very different things. Our 4x is multiplying a 4 by a variable that we are not aware of right now. They haven't told us. It could be 2, it could be 10, it could be 50, it could be a bajillion. We don't know. Right? They're 2 different totals. And then for 7x minus x, you can't just subtract the x. That x is a variable. It could be 1, it could be 2, it could be 4, it could be 28. Right? You don't just take the x away. It would actually leave me with just 1 less x in general. So, although Puzzle Penguin, he's our friend, and I support him, but sometimes he doesn't attend to precision, right? So I'm going to write on here, seen in my model, so you can look at my model and go, oh man, I really need to figure that out. And here's some extra practice for 22. I'm still talking while it's writing, but apparently I write slow and talk fast. So for 22, it's 6m minus m. I could find an equivalent expression that would give me 5m. And some of these might not be possible, right? Because I have my 6m, 1, 2, 3, 4, 5, 6. I subtract an m, and I have 5m. Now, number 23 is 8 plus 3t. Yeah, not going to happen. It's not possible. I can't add the 8 to the 3t. Now, you try 24 and 25 on your own, so put it on pause. Oh, yay, you're back. Okay, so 23 is not possible. 24, 7w minus w, also not possible. I can't just subtract the 7 away. 2 totally different things. Now, if there was a number, we would be talking, but it's not possible. And number 24, 4s plus 4s, I can actually combine those to get a total of 8s. All right, thank you, Mrs. Smith, for helping.